Okay, today we're going to look at some problems from section 5.3. We're going to split this into a couple of videos. The first one, we're just going to focus on graphing square root functions. So we're not going to look at cube root, so just the square root, and some transformations. So we'll do two of those. We'll end that video, and then you can look at the next video if you want for cube roots. Okay. So the first thing we want to do is, or we look at our argument, is we want to factor out that 2, and that leaves us with the quantity 2 times the quantity x plus 2. And so that really helps us to see that the shift here from our parent graph of just the square root of x, the x plus 2, the plus 2 moves it 2 to the left, and then this plus 2 moves it to right. So when we're listing our transformations, okay, so we have 2 left, and we have 2 up. And then this 3, it's going to give us a vertical stretch. Okay, so from here, we're going to find the domain and range. So remember, for the domain, we take our argument, and that needs to be greater than or equal to 0. So subtract 4 and divide by 2. So x is greater than or equal to -2. There's our domain. And for our range, because the graph has been moved up and there's no reflection, we know y is going to be greater than or equal to 2. Okay, so a couple of things. Here's our graph paper. So we've already identified that we are going 2 to the left and 2 up. And we know that the domain is greater than or equal to 2 and the range is greater than or equal to +2. So we want to grab a few other points here to plot so that our graph is accurate. So I think 2 more would be good. So I'm going to choose 0 because I noticed that if I substitute 0 here, I'm going to end up with the square root of 4. And as a general rule, I'm going to list some points over here so we know -2, 2. We really want to pick numbers that will yield perfect squares so that when we graph, we're graphing integers. So just y of 0 would be 3 times 2 times 0 plus 4 plus 2. So that's 0. That's a square root of 4, which is 2. 2 times 3 is 6, plus 2 is 8. And then another point I'm going to grab is 6. Because again, if you see 2 times 6 plus 4 plus 2, so 2 times 6 is 12, plus 4 is 16. Square root of that is 4, times 3 is 12, plus 2 is 14. So there's the 3 coordinates. So here I have 0, 8. Then if I go out to 6, going up, there's 10, 11, 12, 13, 14. And so you can really see the steepness here with a couple of other coordinates. And so this really allows me to be more accurate with our graph. So you can really see the steepness that we talked about with our vertical stretch. So there we've got our 2 to the left, 2 up, our vertical stretch. There's our domain and range, have a few points. Excuse me, and there's our graph. All right, let's look at one other one. So here, notice we have a 9 minus x. So what I'm going to do is factor out that -1. So we have -1x minus 9. All right, so this x minus 9, this is going to move it. And again, I'm going to list our transformations over here. So we've gone 9 to the right and 3 down because of the -3. The 1/2 is going to give us a vertical shrink. The negative in front, that's a reflection about the x-axis. And now this negative on the inside, you see the -x, that's a reflection about the y-axis. All right, so a couple of things. So for our points, we went 9 right, 3 down. So we know we have 9, negative 3. Our domain, so 9 minus x has to be greater than or equal to 0. If I subtract 9, divide by negative 1, and remember when we divide an inequality by a negative, we reverse the inequality symbol. So there x is less than or equal to 9. And our range, now we've gone down 3, but this negative reflects it over the x-axis. So instead of going up, we're going to go down. So we have y is less than or equal to negative 3. So again, I want to list a few more points. So I'm going to substitute 0. So if I substitute 0, I get the square root of 9. So I'll do a little bit of that down here so you can see. So 9 minus 0 minus 3. So that's the square root of 3. So negative 3 halves minus 3. So that's negative 4.5 or negative 9 halves. And then another point I'm going to pick is negative 7. Right, so we have 9 minus negative 7. Well, 9 minus negative 7 is 16. Square root of that is 4. So we have negative 1/2 times 4, or negative 2. So we get negative 5. So negative 7, negative 5. All right, so bringing the graph paper rather. We went 9 to the right and 3 down. And again, we said our domain was, here again is our domain is less than or equal to 9, and y is less than or equal to negative 3. Here we have a few other points, 0, negative 4.5. And then negative 7, negative 5. So negative 7, negative 5 is right there. So hopefully one of the things that you see, we talked about this being a vertical shrink. Notice that, and I know this one isn't really, let me see if I can clean that up just a little bit in there. Not always easy to, maybe that's a little bit better. So notice that this is not nearly as steep as the original curve, or the previous problem, right? The previous problem had a leading coefficient in a value of 3, which gave it a vertical stretch. Here our a value is 1/2, which gives us a vertical shrink. And you can see that that's not nearly as steep as the first one. So hope that helps, and we'll see you real soon.